Hello everyone, and welcome to episode 4 of our Kibana in Action series. And thank you so much for taking the time to join us today. My name is Sarvagya Tiwari, and I'm an Elastic engineer here at Hyperflex. Today, I'll be hosting this session alongside my colleague Dhruvi, who will be leading us through today's walkthrough. For those who are new to the series, this is a monthly webinar where we explore how Elastic and Kibana are used across different industries to solve real-world problems. So far we have covered use cases from travel, retail, and sports industries. And if you haven't had a chance to check those out yet, I highly recommend doing so. They're packed with practical insights. So before we dive into today's session, let me just first. I'd love to get to know our audience a little better. Feel free to drop a message in the chat. Where are you joining us from? Are you already using Kibana, or this is the first time exploring Elastic? Would love that. Like, we always love to see the diversity of our audience, so don't be shy. And let me just share my screen in the meantime. Okay, now before we jump into the demo, let me take a minute to introduce Hyperflex. Hyperflex is an Elastic certified partner, and we work exclusively with Elastic solutions across observability, search, and security. So, whether it is consulting, migrations, upgrades, or any kind of managed service, we help organizations get the most value out of it, of their Elastic environment. And we are proud to have over 20 Elastic certified engineers, including 16 observability specialists and 5 Elastic certified engineers. And our team is globally distributed amongst New York, Canada, Pune. So this global presence usually allows us to support clients across different time zones and deliver projects that require like collaboration and some kind of rapid execution. So we love to bring different industries from different places. So yeah, and one of the key things that differentiates Hyperflex is our exclusive focus for Elastic. It is not just one of our offerings; it is our core expertise. Now, in addition of consulting and delivery, we also specialized in some of the tools we offer. So that includes Splunk to Elastic migration, basically that enables seamless transitions from Splunk to Elastic without any downtime or with minimal downtime. We also provide Elastic seamless upgrades. This usually allows organizations to move between any version of Elastic very smoothly and safely. So now coming back to today's session, I am very excited to introduce Dhruvi. Dhruvi is an Elastic engineer at Hyperflex, specializing in search, and she has worked extensively with real-world clients, so across multiple industries. So she'll be walking us through today's episode of Kibana in Action, which is focused on e-commerce sectors and specifically search and analytics part of it. So showing how showcasing how we can use Elastic and Kibana and gain some meaningful actionable insights from it. So without any further ado, I'll hand it over to you, Dhruvi.
Thank you so much, Savagya. Good morning, everyone, and thank you so much for joining this session, Kibana in Action for e-commerce, specifically for search and analytics. So, in today's webinar, it's going to be a technical walkthrough of how modern e-commerce platform use Kibana as their real-time analytics and decision layer on top of their search telemetry. So, what you will see today is how real user behavior, their search, their clicks, their abandonment, and relevant signals become measurable, explorable, and actionable inside Kibana. So the key theme I wanted to keep in mind throughout this session is in e-commerce, search and quality directly impacts the revenue. And Kibana is a system that allows us to see, allows us to measure, and continuously improve that quality in real time. So we will more deliberately from architecture to data modeling to dashboards and finally to the live analysis pattern. Now I will spend also time explaining the metrics, the terminologies as we encounter them. So whether you are new to the search analytics or already operating in Elasticsearch in production or a shopaholic like me, I'm sure that you will be able to follow this entire story. So yeah, basically modern e-commerce system are what I like to call event factories. So every single user interaction generates data. A search query generates an event, a filter click generates an event, a product click generates an event. So even a user doing nothing and leaving the site generates an event, and that event is extremely valuable. So think of it as you are just surfing your Amazon website. You want something called an iPhone, right? And you're just scrolling. Every single thing that you do on that particular app generates events. So the competitive advantage today is not having data, right? So everyone has data. The advantage comes from how quickly and accurately we can analyze that data to detect any relevance issues, any behavioral shifts, and any conversion blockers before they impact the revenue. So in this is where Kibana comes very critical to us. So Kibana is not just visualizing logs or metrics. It is more of an in an e-commerce context, Kibana is basically answering the business critical questions to us, such as which search is frustrating users right now, which queries return results but get zero clicks. Are our relevance changes actually improving the engagement? Are user finding they what they want faster today than they were yesterday? And do people exactly do that? And we get answers of our queries. Do we get answers of queries in the first three response? And so on and so forth. So all these questions require real-time, high granularity analytics, and that is exactly what Kibana excels at. So before we go deeper into Kibana, let me quickly anchor everyone to the architecture, right? So at the application layer, we have an e-commerce front end, whether it be mobile or a web application. So this generates search requests and behavioral events. These events flow into Elasticsearch. And Elasticsearch plays a dual role here. First, it powers the live search experience, and second, it stores the high volume analytics data generated by the user behavior. So now here is the critical architectural principle, right? So Kibana queries the exact same data as Elasticsearch that powers the live search. So there is no mid ETL job, there is no secondary analytics warehouse that is needed, and hence there is no delay between what user does and what we see. So this means Kibana is operating on a single source of truth with near zero time latency. So when a user clicks on a product, that click is visible in Kibana almost immediately. And this tight coupling is what allows real time optimization and not just some retrospective reporting. So Kibana's analytical power is directly dependent on how well search events are modeled, right? So in this system, we capture several categories of telemetry. First and foremost is the search queries themselves. So the raw query string, all the applied filters, the result count, the latency, the timestamp, and the session identifier fall into this category. Secondly, we have quality indicators. So things like zero result searches, high exit queries, and the refinement chains where users repeatedly modify their query. Third, we have engagement events, so like click positions, product ID, dual time, and add to cart actions. And finally, we have contextual data, so geography, device type, A/B test variant, and the platform metadata. So all this data is indexed at a full fidelity without any pre-aggregation. Why this is important is because Kibana thrives on high cardinality fields, right? So query strings, SKUs, the session IDs are not problem for us; they are a feature. So this slide I think is most important of all, especially for anyone that is responsible for the platform performance. So first, these are the time-based indices. That means the data is organized chronologically, and this enables efficient trend analysis, alerting, and lifecycle management. So Kibana's time picker is not just an UI element. It is an architectural assumption. Second is the data follows Elastic Common Schema or ECS. So ECS basically is a standardized field naming convention that Elastic provides. So this basically defines how fields like timestamp, user identifiers, geodata, and even metadata should be structured. So basically, an ECS aligned data or an ECS aligned architecture means that the dashboard that we are creating is going to be reusable. The visualizations are going to be much more predictable, and teams speak a common analytical language. So, and here is the key point, right? A good Kibana performance is a data model and decision, not a visualization trick. So when the data is ECS aligned and time based, Kibana becomes much more faster, intuitive, and scalable. So at this point, Kibana becomes the control plane of an e-commerce analytics. So Kibana allows us to move seamlessly from any high-level trends to individual queries and product. So we can filter, we can drill down and correlate matrices across dimensions in seconds. And this is not static reporting. This is interactive analysis. So the dashboard that you'll be seeing today is designed to support investigation and not just the observation. So we have multiple tools for that, basically Kibana Lens, Kibana Maps, the round filters, and everything you're going to be seeing in coming of this lecture. So this is the slide where we basically formally connect the user behavior to the search quality, and this is one of the most important conceptual movement I think is for this webinar. So when we talk about search quality, we are not talking about whether the search is working or not. We are specifically talking about whether the search is helping user achieve intent efficiently or not. And there are three primary decisions we measure here. So first is the query volume versus the engagement. So high query volume with low engagement is a big red flag for us. It means that users are searching, but they are not finding compelling results. Kibana allows us to overlay query volume with click-through metrics so that we can immediately identify demand without satisfaction. Secondly, we have high exit and abandonment patterns. So these are the queries where users either leave immediately or perform no meaningful action. So these patterns are often invisible in a traditional analytics tool, but in Kibana, they are first-class metrics that can be trended, that can be filtered, and that can be segmented. Third is the seasonal and driven behavior shifts. So, search behavior changes during the promotion, the launches, the holidays. So, whether it's Christmas or whether it's Thanksgiving, there is going to be a change in. There's going to be a shift in what consumers are supposed to be buying, what they like to buy at these particular time. And Kibana's time-based analysis allows us to compare this behavior week over week, season over season, campaign over campaign, without having to rebuild this whole report. And the key point here is that Kibana does not just show us metrics, it allows us to correlate relevant signals across time, the query intent, and the user behavior, which is what makes the optimization possible for all this. I would like to, of course, enough of talking. Let me go through my Kibana and show what I exactly meant. So this is my basic website, your Amazon, eBay, or anything, whatever e-commerce website for now. So yeah, like every other website, it has shop now, seasonal opens and anything and everything. So let's say I need to buy an LCD TV. So I'll search for LCD TV over here. And voila, I have so many options for that. Now we have to keep in mind that everything that I do on this website, like I mentioned before, is generating an event. Me searching for this LCD TV in the first place, me putting any filter. Let's say I want a TV that sits in my pocket range that is for 100 and $149. So if I apply that, I get this result, and everything, even the minute of the things generates an event. If I click on this, it's going to generate an event as well. If I'm adding to cart, it generates an event. So anything and everything generates an event, and all these events are stored into Elasticsearch. So basically, think of this as a pipeline, right? So in this case, particularly for the pipeline, I'm using Beats. So Beats is the one that is taking all this event data from my application, and then this is storing everything into Elasticsearch. So if, as I have this already open over here, if you see, so this is the discover page where we are able to see all the logs for Elasticsearch, all the log events, right? So these are all the events that has been generated from the website. So let me, so I will just open up an event for you guys just to show how this data looks like. So this has all the fields that is there. We have event tags, uh, query timestamp and anything and everything. And if I go over here, yeah, I think this looks pretty good. Okay, so in event tag, it says products. The source is the corporate website, which is the website that I was using. Then we have agent name. I'm using FileBeat as I mentioned, so let's skip that. Then we have timestamp, and we have so many things. We have FileBeat again, and also Another thing that comes in very handy in such condition is having a count based on geolocation. Now, different countries have different holiday patterns, different celebration times, so it's really easy to analyze the trend and pattern over time based on different country. And for that, Elasticsearch basically provides this functionality of having fields like geospatial. So in geospatial, we have longitude and latitude that basically records the longitude and latitude, the coordinates from where the query is triggered. So let me show you that. So if we go here and we just do uh, here, uh, yeah, so I think based on the our longitude and latitude, whatever the last event was from, it found that a country turned out to be China. And for different logs, you would be having different countries and things like that. So now, if I have to see like what is the product that is trending most right now, so what I need to do, I just need to put query string. I just put string. I think that's easy. Yeah. So if I do string. Now here I'll be able to see like 4.5% of the total search queries were for LCD TV, 3.9 was for iPad, then we have for Kindle Fire and so on. But for me, I think this data is pretty boring. I mean, the way it looks like to me, it's really boring. So let me do the magic and take this to the visualization. And voila, we have the visualization. And but still, I think the other is way too dominating for the my actual products. So let me get rid of the other part. So I'll go over here, go in advance, and I'll disable this group remaining as others. And I don't want the 5 values, I want the 10 values. Now I have 10 values of what is the most trending product and what is the least trending product. I mean, not least, but at least in the top 10. Another thing that is really cool in this is that we Elastic also suggests if you can make different visualization out of this. So if you want a heat map, so like there is 197 request, sorry, 120 request for LCD TV. There is 188 requests for iPad. So we have different type of visualization. We have trees, donuts, waffle, tag cloud. And I think for me, tag cloud was the best because it looks really, really cool. It has this LCD TV in between, and it's really easy for me as a developer to understand, oh, okay, this is the frequent searched one, and this is something that I need to advertise more or something that I need to promote more. You can also save this visualization. And so if you go here and click on save, it would ask you to give you a title and then a dashboard that you should already be having. Uh, in your Elasticsearch cluster, even if you don't have it, you can just click on the new and click and create a new dashboard out of this. But because I have one already created, I won't do this and I'll take you there directly. So let me just add this to the dashboard that I already have. I'm just naming it query, but of course, make sure to name it much more sensible because for me right now, because of the demo, I'm just naming it something. So yeah, if once this get, oh yeah, see, I had one previously created. Okay, so the one that we just created got added to the dashboard, this which I already got created before. So Mm, okay, yeah. So let me. So this dashboard basically, as I mentioned, right, this is for the investigation purpose. This is not for observation, not for oh, this looks cool. No, this with the help of this particular dashboard, we can get the real insights for the data. So as the first one, the name suggests, right, this is the query volume. So this is the query volume per hour. So I mean, in the last hour, if I can see, there were like 70 queries, and out of those 70 queries, I can easily see with the help of click counts, there were only 60 clicks. Like, I mean, 70 people were there who raised a query, and and out of that 70, 60 people clicked. So 10 people were there who would queried for something, but did not click on anything. That might be because of the product issue. They didn't like the product. They didn't found what they were looking for. But yeah, that's the gist. Next, we have CTR3. So this is basically, um what we can say. So this basically makes you understand that uh, out of all the query results that you are getting, what are the chances that the other person is clicking on the third result? So this at the rate 3 means 3. So third result, we can have CTR at 1. That means how many, I mean, out of the, if I'm querying something and I'm getting results, and out of those results, how many people are creating clicking on the very first result that I'm getting out of query. So I have this for third one. Then we have query low click number. So this is the least. Uh, I mean, what this means is somebody queried for something, but this had the least amount of chances to get clicked. So iPod Nano had literally 9 click counts. That's the lowest of all. And then iPhone case has 19 click counts. So I mean, somebody queried for things and results were not satisfactory. So hence we have a really low click number. Next, we have top queries. I think this is similar to what I did before. We have result for what is trending most right now, which is LCD TV, and then we have iPad, we have iPod, and so many. You can tailor this according to your needs. If you want to see top 30 values, you need to see top 40 values, and whatever works for you. Then we have top queries with zero results. So this is interesting, So a zero result query basically means that users search for something and we returned nothing. So this is often a content gap, a synonym issue, or a catalog mismatch. So these queries are highly actionable because they represent the explicit unmet demands of users. And next to that, we have this top queries has results but zero click. And this is actually much more dangerous because it means results were returned, but users did not find them relevant enough to click. And this is the relevance problem, not the content problem. So Kibana makes this distinction visible instantly, and that decision drives very different optimization changes. Now, easily by looking at this, I can understand. Oh, okay, laptops were being populated, but somebody was not. But the user is not clicking to this. There should be some issue with the content. So either I need to promote some new laptops or anything. I mean, that goes with your personal strategy. Another is we have mean reciprocal rank. So now if you have MRR or mean reciprocal rank means how high the first click result appeared in the rank. So conceptually, if users consistently click the first or second result, MRR is high. And if they have to scroll or they never click, MRR just drops. So MRR is, I think, one of the most important relevance metrics because it captures the ranking quality, not just the engagement volume. And Kibana visualizes MRR as a time series data. So this allows us to see the impact of relevance changes, algorithm updates, and any catalog shifts over time. Next, we have time to clicks, and this has the first time to first click and then time to last click. The so the time to first click measures how quickly a user is finding something worth clicking, and then time to last click tells us how long did they continue shopping. So shorter the first click generally indicates the better relevance, and Kibana allows us to trend these metrics and segment them by query type, device type, geography, and detect any regressions immediately. Next, we have clicks per query. I think that is again self-explanatory. For a query, how many clicks do we have? So clicks above fold is one. So I think all the results that were getting populated on the very first page, users were clicking, and percent is I would say rather ratio is 1.196, and nobody was going to the second page because clicks below fold is 0. So that is that. And then we have abandonment rate. So abandonment rate measures the percent of searches where user performed no meaningful action and they just left. So this is basically what we can call a silent revenue loss for us because users, they do not complain to us. They simply leave. So by visualizing the abandon rate over time and correlating it with the query patterns, Kibanas allows us, or rather companies or teams, to prioritize the most damaging search failures for us. And one thing that I would like to go over is this map. So I think this is some real cool stuff. Here, as I mentioned earlier, right? So we Kibana also has a field type called geospatial data, and with that we can capture the longitude and longitude and latitude for from where the query has been triggered. So here we can easily see that the East Coast is making much more queries. They're engaging with our application more than the West Coast. So we can promote our products accordingly. We can, if you want, if that goes with your strategy, you can promote the products that are native to, or the some small brands that are native to East Coast rather than West Coast. And then according to that, if there are more queries from West Coast, we can do similar or vice versa. And this is one that I already explained. We can easily see the LCD TV has the most number of queries. So yeah, I think that's that. Let me quickly go over to A/B testing. Yeah, so finally, this is where Kibana truly shines for the experimentation. So here we are comparing a control relevance model with an experimental variant. So we can see click counts. We can see click counts side by side. For more fields, if you want, we can add more aspects to this, like engagement lift. We can add some user behavioral changes. And for me, because this was a demo, I just went with one parameter, but you can add, of course, according to your call. And because of this is happening in Kibana, we can filter by query, we can filter by time range, we can filter by geography or product category instantly. So this enables a statistically confident decision without exporting data or waiting for any offline analysis. So if you see right here in our control group, the top performer for us was security camera from Lorix. This in white variant, so I think there were 22 click counts. And then for experimental group, the Mayfox security camera and with privacy shutter in white and silver was the top performing. This had 16 click counts. So this is not the query count, this is the click that user actually queried and then clicked this specific product. So if I had to combine, I can see the ALC wireless IP security camera in black is my top performer for both because it's on second position for both. So irrespective of my control group or experimental group, I think this is best performer for me. And yeah, that is how we can do A/B testing for this as well. Yeah, so going forward, I think this slide represents the operational maturity stage of search analysis. So once you can measure relevance, the next step is to systematically improve it. And Kibana is the platform that enables us this feedback loop, right? So first, A/B testing dashboards in Kibana can compare control and experimental relevance models side by side. And these dashboards, these are not static. I mean, we can filter by query class, by device type, by geography, or traffic segments in real time. Second, variant level and uplift analysis. So we are not just asking whether clicks increased. Moreover, like we are asking whether where they increase, for which queries they increase, and for which users did they increase. So Kibana's drill down capabilities allows us to isolate the true impact of changes. Third is the proactive alerting. So Kibana alerts can notify teams when zero result queries spike suddenly. So when MRR drops or when abandonment increases beyond a specific threshold. So this moves search quality from a reactive process to more of a monitored system. And finally, there is the relevance governance. So instead of one-off tuning exercises, teams operate continuous optimization cycles backed by the measurable outcomes. So let's close by tying the technical capabilities back to the business and architectural impact for this. So, from a business perspective, Kibana enables the measurable relevance. Search quality is no longer subjective. Improvements are quantified using engagement metrics, ranking quality, and behavioral outcomes. So, this directly translates into conversion growth. And when users find what they want faster, they engage more, of course. And when engagement increases, conversion follows. So Kibana makes this relationship much more visible, much more defensible. So from an execution standpoint, I think teams move much more faster because decisions are based on the live data, not the intuition or some delayed reports. And relevance changes can be evaluated in hours instead of weeks. And architecturally, the most important takeaway is this that Kibana is not an afterthought analytics layer. It is more of a real time analytics backbone, tightly coupled with Elasticsearch. And there is no ETL lag, no data duplication, and no analytical blind spot for this. So when a Kibana is designed into the system from day one, search platforms become much more observable, much more optimizable, and governable. So that is what enables continuous improvement at a scale. So I think, yeah, that's it from me. And I'm happy to take any questions if there are.
Okay, guys, the floor is open for a few questions. Okay, we do have a question. So can Kibana help us see exactly where customers drop during checkout?
Sorry, I lost the question in between.
The question is, can Kibana help us see exactly where customer drop during checkout?
Yes, so Kibana can show us precisely which checkout step users abandon, how that changes over time, and which segments are more effective, all in near real time.
Perfect. And I think we have another question. Why not send this data to a data warehouse instead of using Kibana?
Yeah, that's a very good question, actually. So basically, a warehouse is an excellent retrospective, a batch-oriented analysis, but e-commerce search optimization is much more a real-time problem for us. And Kibana operates directly on top of Elasticsearch data with near zero latency. So that means there is no ETL delay, no schema drift between the system, and no loss of granularity. So we are analyzing the user behavior as it happens, not hours later.
Perfect. I think we have one more. I think we have time for one more. So, how does ECS alignment actually help Kibana?
Yeah, so basically, ECS standardizes the field names and data types across the events. So this means dashboards, filters, your visualizations work consistently across teams and indices. So from a Kibana perspective, ECS dramatically reduces the dashboard fragility and accelerates the analytics development because everyone is speaking the same analytical language and everybody's on the same page.
Thank you. Thank you so much for clarifying that, Ruby. So, I think uh, once again, I think we will end the Q&A there. And thank you everybody for joining. Thank you so much, Dewey, for walking us through this. This was incredibly insightful, and I'm sure everyone is walking away with a much more clearer understanding of how Elastic and Kibana is getting used on e-commerce in terms of searches for search use cases. And before we of course, a big thank you for everyone who joined today. This session is a part of our Kibana in Action series, which is ongoing right now. But beyond webinar, we also host meetups. We also do podcasts and blogs. So thank you everyone for joining again. Elastic, we usually keep the webinar meetups and podcast blogs around Elastic knowledge and real world experience. So if you like to watch our past episodes and stay updated on upcoming sessions, I highly recommend visiting hyperflex.co. And if you're interested in collaborating with us, whether that's joining a webinar or a podcast, feel free to reach out to us at marketing@hyperflex.co. And of course, don't forget to follow us on YouTube, LinkedIn, Instagram. We regularly share our updates, our demos, all our Elastic focused content there. Now, once again, thank you all for joining today. We really appreciate your time, and we are looking forward to seeing you in the next episode of Kibana in action.